Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the longest consecutive sequence problem. I'm on holiday at the moment, so this is a pre-recorded video. I'm sure I'll be back soon. Right, given an unsorted array of integers nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in order n time. So the input nums is equal to 100, 4, 200, 1, 3, 2. The longest consecutive element sequence is 1, 2, 3, 4. Therefore its length is 4. Okay, so here we can go 0, 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Yeah. So we can't have the two zeros, basically. We have to discard one of them. This is rather tricky. So my immediate thinking is we need to do some sort of lookup. If I'm looking for a 100, I need to know if I have either a 99 or a 101 already seen. If I've seen one of those, then I can increase that sequence by 1. If I've seen both of those, I can add them together and add 1 to the result, and that's a sequence I've made. So here, for example, the 4, I haven't seen a 3 or a 5 yet. So the longest sequence is 1. And the 200 isn't going to do anything, so we'll skip it for now. The 1 isn't going to do anything, so but I will explain what I'm going to do. I'm going to basically say, well, look, I've got a 1, and it's a sequence length of 1 is associated with it. I've got a 3, and that, there is a 4 I've already seen, and that had a sequence length of 1 associated with it. So what I want to do is basically say, well, this had a length of 1 and I can extend it by 1, so these two now have a sequence length of 2 associated with them. And when I see the 2, I see there's a 3 and a 1. This had a sequence length of I've got a problem here. That's got a sequence length of 1 associated with that. It's got a sequence length of 2 associated with it. So overall I get a sequence length of 4 associated with it. But the problem is, what if I then saw a 5? Did I have to update the 4 as well? That's interesting. Because if I see a 5 now, I can go to the 4 and say, well, how long was your sequence? And somehow it needs to know it's in a length 4 sequence. Maybe I don't want to do that. Maybe I want to do something a bit different. I think what I want to do is actually a disjoint set algorithm now I think about it. So they're initially all in separate sets. With the 100, I look for a 99 and a 101 and see if there's a set for either of those. There isn't. Then I look at the 4 and I see, is there a disjoint set for either of those? No, there isn't. 200, I'm looking for a 199 or a 201, nothing there. 1, I'm looking for a 0 or a 2, there's nothing. 3, I'm looking for a 2 or a 4. There's a 4, so I want to join the set with a 4 and the 3. Those two need to get joined together. Then I see the 2, and there's both a 1 and a 3 set, so all of those need to get put together into the one set. I think that's what I want to do. The disjoint set is going to be list range len nums. That is our default disjoint set. Everything is its own representative. So if you've not seen a disjoint set before, the way it works is basically every element is marked by its representative. So if two elements have the same representative, they are in the same disjoint set. If they have a different representative, they must therefore be in different disjoint sets. The way that basically we store the representatives. Now I can never quite remember how this data structure works. So when I have the 4 and the 3, what we can do is we can say, well, what are your representatives? Well, they're 4 and 3, and all I need to do is point one of them at the other. So I would point the 4 and say its representative is actually the 3. In this case, it's their index, not their actual value, but the point remains. So this would have a witness of 1, and this would have a 2, 3, witness of 4. A representative, sorry, of 4, because that's their index, but it doesn't matter. Yeah, that's correct. So, what I want to get representative. Let's actually make this a local thing. Self I. While true, rep is equal to self dot disjoint sets I. If rep is equal to I, return I. Else I is equal to rep. And the way this works is basically, if we're looking at index, let's say this was wired up. No, let's say this 3 here, which initially had representative 4 because it's in position 4, was now set to have representative 1 because it was in the same disjoint set as the 4. So we would go here, we would say I'm looking for the witness for the representative position 4. I'd say, okay, well, its representative is 1. Does 4 equal 1? No. So I'm going to say, well, now I'm looking for the representative of 1. And that will be 1. So then we return 1. And so on and so forth. Right. So now let's say for I, V, I'm just trying to think, how can I think I need to map every integer in here to its first. No, I thought I had it for a second there, and I only got myself confused again. How can I know? I've never seen it before. Okay. For IV and enumerate nums. So I'm going to keep here this indices dictionary, which maps each value to its first index. If I minus 1 in indices, and I plus, sorry, not I, V, and V plus 1 in indices pass. In fact, let's do something first. If V not in fact, if we've already seen a 0, for example, seeing another one is not going to do anything. So if V is already in the indices, continue. Right. Elif V minus 1 in indices elif v plus 1 in indices pass. And if neither of those things, what we want to do is we want to say indices, well, no, always we want to say, in fact, indices v is equal to I. So here we're going to look at both the, so vrep is going to be self.get representative of I. V predecessor rep is going to be self.get representative of indices of v minus 1, and v successor representative is going to be self.get representative of indices v plus 1. So then it's going to be the representative is the minimum of v rep, vp rep, vs rep. Those need to go in a list, I think. I can't remember exactly how min works, and it's very confusing. So then I just want to say disjoint self disjoint sets of v rep is equal to rep. Self.disjoint sets of v predecessor rep is going to be rep, and self.disjoint sets of the successor rep is going to be rep. So this is basically forcing all of them to point to the same representative, marking them as all being part of the same set. Right. Down here, I want to do very nearly the same thing. In fact, I can just pull this guy. Whoops, that's not how that works. We always need we always need the vrep, the representative of the current value. But these two here, we kind of want to do a lot of it similarly. Why didn't that take? I want those. That's better. Prep. Good. And then over here, well, I want to take all of this again. And do it here, except now I don't want the predecessor stuff, I just want the successor stuff. Right. Whew. See, I've just thought, I hope this counts as order n time, because this can take, God, I guess in theory it could take up to order n time. It really shouldn't. Be very unlikely, but I guess technically it's possible. So let's just see how far we've got. So here we're seeing 0, 1, 2, 1, 1, 1. Great. Those are the correct disjoint sets. And here we're seeing 0, 0, 1, 1, 1, 2, 1, 1, 8, 0. I think what needs to happen there is we need to do a normalization pass, isn't it? I in range len self dot disjoint sets self dot disjoint sets I is equal to self dot get representative I. No, I don't want to do that normalization phase. I'm just going to go through this in a slightly different way. Oops. Let's move our print statement up here for a moment. So now it's going to be this thing's witness representative is 0. So what I want to do is I want to get the representative set. Oops. Let's get a representative, which now should be fairly canonical, because these may have been set all at different times, which is awkward. So here the 1 points to this, and then it should then connect to 0. It's just because of the order these things were set, we didn't know they were in the same set until much later on. So it's only at the very end, when we've computed all these disjoint sets, that we can actually truly compute its representative. If rep in sets rep plus equals 1, else sets rep equals 1, print sets. Let's check we've now calculated all of the sets correctly. So there was, in set 0 there was 1 thing. That makes sense. In set 1, there were 4 things. That's good. And in set 2, there was 1 thing. That's good. And in this one here, in set 0, there were 9 things. That's good. And in set 8, there was 1 thing. That's good. That's what we want. We want to see that. So now, we want to basically do a return max sets.values. Perfect. Is this order n? Well, this is order n, building our disjoint sets. At the end, this is order n. Is it? So the question is, this get representatives business, how slow is it? In the worst possible case, our sets could be very long and dangly and annoying to work with. That seems very unlikely, though. I'm just trying to justify to myself that this is order n, but I don't think it is. But I don't know how you could do any better. That's the problem. As soon as we sort it, we've got n log n. Unless we do something slightly cheaty like a radix sort. Well, that's probably not in the spirit of the question. What I'm trying to do is build chains and somehow link the chains together in a very quick way. Actually, maybe I don't need to get the representatives here. Maybe all I need to do is keep track of the indices. What happens if I do that? So let's tweak some things. vrep is equal to I. And then VP wrap is equal to indices v minus 1. And the successor is indices of v plus 1. Then the same thing down here. Predecessor representatives indices of v minus 1. And the successor is just indices. Now these are fast. These are very fast. But are they still correct? That's what I don't know. No, they're not correct. I'm curious as to why that is. Oh, because there's no real link between them anymore. No, so that's not correct. I get why. There's a reason the disjoint set algorithm is the way it is. Okay, I'm not convinced this is actually order n, but I'm going to submit and see if it's quick enough. Oh. I guess, yeah, it was the empty list case that I hadn't handled. Apparently that was quick enough. I'm still not... Oh, apparently I tried this one. When did I try this? No, that was 2020. God, okay. And I got it right then too. How did I do it? Oh. I just sorted it and said assume counting sort. Right. That's a bit cheaty of me back then. I probably should have coded up a counting sort, because that's that all that does is it sorts them, counts a run, and then carries on. This one at least is a little bit more clever in trying to join chains of runs together in a fairly efficient way. It's just this getting representatives that I'm not entirely convinced is effectively I need it to be order 1, but it can't be order 1. But if I can bound it in some way, no, I don't know. Not the best solution to this problem. I'm still not sure I've found the right solution to this problem. Do let me know in the comments. Obviously I'm away at the moment, but I'll read them when I get back with great interest on how you're actually meant to solve this problem. Anyway, that's it from me. I will see you next time. Bye.